Excuse me. Welcome to COSE. Yes, Ivo, if you'd like to share the chair slides, please do that. Thanks to Brian Campbell for the image of Thailand. So if you've been to working group meetings before or you've signed up for the meeting, you've seen the note well. It allows us to use your contributions or not. Also, we are expected to treat each other well. So let's do that today. So there's a number of resources and meeting tips. And again, these slides are in the data tracker, so you can find these links and use them. Now it's action time. I need one or more thinking adults to take notes during the session so that we have a record of the decisions we made. Could I see a show of hands for who is willing to contribute to note-taking? Yaron, could you take notes? Thank you. Steve Venema, could you help him? Thank you very much. So the chair's put together status on a few things that have occurred since we last met our heroes. COSE key thumbprint is now an RFC. Congratulations to the authors. Merkle tree proofs has been submitted to the IESG for publication. The timestamp token has been submitted to the IESG for publication. Dilithium, aka MLDSA, has been submitted to the IESG for publication. And BLS key representations is once again continuing to wait on the CFRG PBS signatures draft. So there's no updates on that today. This is our agenda. You'll notice that there is 0 time at the end for adding things. If some of the presenters are quick, we may be able to reclaim some time, but Hannes will be quick. Okay, Steve will be quick. With that, let me welcome Brent Zundel to the stage to present about Sphinx Plus and Falcon first. Ivo, can you share those slides?
Hi, folks. My name is Brent Zundel, and I don't belong here. I'm presenting on behalf of Mike Prorock and Ori Steele, neither of whom could be here at this moment. So if you have really hard questions, that'll be fun. All right, first up, in the beginning, there was some post-quantum crypto that came into the group. It was a single document. As time went on, that document was split into 3 separate things, and we're going to talk about each of them separately today. First, we have Sphinx Plus and Falcon. So we're going to talk about what's happened and what the next steps are for each of these. Sphinx Plus update, we have the CMS Sphinx Plus is in RFC editor's queue. So it's in a good place. It's done, essentially. COSE Sphinx Plus is active. It's using the key type from MLDSA. There's a lot of different algorithms still possible in it. And so the question to the group is, can this be limited? Do we need all of these? Can we at least say SLH, DSA, SHA-2, 128 is something that we're all going to use? Is there anybody who's not going to use this one?
John Mattsson, yeah, MLChem and MLDSA use SHA-3 internally. Ericsson and I know some else are planning to migrate to SHA-3 in the PQC transitions. I would be against limiting to SHA-2. I definitely want Shake. That is the only variant my company is planning to use.
Cool. My understanding is not to limit it to just this one, but to make sure this is one that we all can use. So I think SHA-3 sounds, I think that's still fine, but this will still need another version to be published, though. Any other Sphinx Plus comments before we move on to, all right, Falcon. This draft is expired. Nobody who was working on it really wants to keep working on it. and nobody has really seemed to care. So the question to the group is there any reason that this document shouldn't just be abandoned? Oh, I think, Philip, you're on the queue.
Correct. Can you actually go back one slide? Thank you. I have a short talk tomorrow in the COSE working group about an upcoming WICG draft to extend web crypto, which has an intersection with COSE JWK algorithms. So I had a question, and I think you answered, but I wasn't 100% clear. Are you still going to try and define all the possible JWK algorithms, but then limit the actual signing definitions to just one?
Define all the possible what algorithms?
COSE algorithms to use with JSON web key representations.
I don't know the answer to that. I'm
Okay.
just presenting today.
Okay, thank you. One of the authors, maybe remotely, I don't know. The point or the problem with the AKP key type is that the algorithm is required in that one. So if there isn't an algorithm registered for the use of a given algorithm, we can't export it from the Web Crypto API implementation in the future. Which is something we were able to do with ECDSA algorithms in the past, even if we didn't have a particular algorithm in mind, because the EC key type allowed it. AKP doesn't. Anyway, I'll reach out to Ori and the other authors.
Yeah, I think
Philippe,
having,
can you put that on the list as a,
Yeah, I will as soon
Thank
as
you.
I finish my presentation tomorrow. I will have more, more material to share tomorrow.
cool. John?
Yeah, John Mattsson, Ericsson. I think nobody wants Falcon Swings dilithium. So going to the question about Falcon, like, I think this draft is just too early. Like, NIST has published specification of SLH DSA and ML DSA. There is not even a draft specification just of FN DSA. So I think FN DSA makes a lot of sense for COSE, but we cannot publish this as an RFC probably in 2 years. So I don't think it should be abandoned, but I think we need to acknowledge that this will not be published for a couple, maybe 2 years. Yeah.
okay, so if I'm understanding right, you're saying let's not kill it. Let's just wait and see if in the future it's revivable. Or
Yeah, I haven't read the draft, but it's probably a good start. But we need to wait for the final NIST publication, which probably takes 1.5 to 2 years. Yeah.
Hannes?
Yeah, I was basically coming to the mic to say more or less the same. It's like, it's not really killing the document, but maybe moving it back to sort of in an individual document rather than a working group document. So you just let it sit there and then resurrect it once the time is right. So it's not a bad mechanism. It's just, it's just the way how things worked out in the grand scheme of things.
I mean, like I said, it's already expired. So is there doesn't seem to be a step to take beyond that. So, all right. Any other Falcon comments or Sphinx comments before we move to my second presentation, which I'm unqualified to give?
All right, let's go to the dilithium MLDSA presentation.
Hi, folks. My name is Brent Sundell. I'll be presenting on dilithium for the group today. Mike Prorock and Ori can't be here. Mike is probably asleep in Montana, or he is being an AD or something. We'll be talking about the update, a proposal for how to align with LAMPS, and some next steps. As far as status, working group last call finished. It's entering AD evaluation. As part of that evaluation, there was a question, how is this draft going to fit with what LAMPS has decided on how to represent private keys, or how will it, because LAMPS is still making that decision, to my understanding. Essentially, this is what LAMPS has settled on. I'll allow this for folks who haven't seen it yet, just to let that sink in. Okay. So they want private key to consist of either a seed or an expanded key, or both, which means for COSE, it would be an inclusion of this private expanded as a value. And for Jose, again, private expanded as a value in order to be unified with what LAMPS is doing. Happy to take comments and field questions as possible, but this is the direction the authors are intending to go, and so feedback from the group is invited.
You may not know this. I don't know if anybody in the room has read it recently enough to know this, but as an individual, my question is, are the COSE and Jose representations of the keys intended, of the private keys intended to include the X509 snippets or just the actual key data? I hope it's the latter, but we should review it to that end.
I don't know.
Okay.
Didn't Russ say it also includes the ASM1 snippets? At least that's how I understood it.
For LAMPS, yes. I sure hope we don't do that. Anyway.
Okay.
Okay. So next steps would be to add the support for expanded private keys. That would be in the next draft version. Make sure that the text that is in the draft about how to handle when both are present, the seed and the extended key, just mirrors whatever LAMPS produces to that effect, because they have to also deal with that. And then any other comments that come out of the AD evaluation will need to be addressed. So, and that's it.
Any questions for Brent or things that you would like to put into the notes as questions? All right, Brian, you're up.
Hello, thank you for your time. Do you want to share the slides, or is that something that I can do? This will be thankfully short and simple. Thanks for scheduling time at the COSE working group for this request. What I'm looking at is that there is currently the ability to run AES in GCM mode without any plain text in order to operate it as functionally as a Mac. This is a little bit different than other Mac algorithms already registered with COSE, in that the AES GMAC requires an IV nonce value as input. So it's slightly behavioral differently. And The reason originally for wanting to do this is because there's pretty wide support for hardware acceleration and even in software optimization of running AES GMAC. So the target is for using high rate and high volume MAC processing in the data plane for a relatively high rate network. And go to the next slide. There's a draft prepared. It's pretty simple. It's really just registering code points and not defining anything new. The algorithm was already specified as part of a NIST document. So this is just making the same references to the same documents as what the original AES GCM registrations were, but for being used in the MAC context. And so that would be the COSE MAC and MAC0 structures. This was originally presented as an option for COSE and HOSE, and the use case of high rate, high volume traffic integrity checks was really not well received on the HOSE side, just because that's not the kind of processing that they intend on doing. But I believe that there is still value in having this on the COSE side, just because when dealing with the COSE's tight binary encoding, it's to me a good fit for this kind of application. So this would register just these algorithms. There already are parameters related to full IVs and partial IVs in the data plane. So this is not trying to make a wide allocation of new material. So I'm offering this as is the COSE working group interested in this kind of allocation in the algorithms registry? And that is my material. So I'll take questions if you have any now.
You have one more slide.
It's a trailer.
Oh, okay. Who in the room has read the draft? Or if you're online, you could say so in the chat. I see no one. So who is willing to review the draft?
One other thing I'll mention as an aside, because it did come up in IANA early review, is that because the application we're looking for is pretty high volume traffic, the code points that could be allocated here don't need to be short and small. These could be relatively large and not in the tightly controlled small number area.
Okay, so you don't need one of the 1 byte
No.
for instance. That's good to know. I still need reviewers for the document if we're going to consider it. Speak to the mic if you're going to speak, Hannes.
Well, there's not much to review because it's just a sort of registry allocation. So like, what would we actually review? Whether the registry is
There
correct?
is a draft that does the registry allocations.
Right.
And I would want a minimum of 3 people to have read it before we consider adopting it as a working group document.
Okay, I can read it. Takes 5
So,
minutes.
Hannes just volunteered. Can I get 2 more volunteers?
We have one already in the chat, Roy Williams.
I'm not able to follow the chat and share.
Mike, this is Roy Williams. I'll read it.
Okay, thank you, Roy. That's 2.
Kathleen Moriarty, I'll read it, but I'm going to request a nudge from the author.
All right, thank
in
you.
Email, so I have a link and make it easy for me. It's 2:24 a.m. Thank you.
Thank you, Kathleen.
Same, yeah,
So
thank you.
people, please put review comments on the mailing list so that others can see what you say about the document. Others can feel free to volunteer to do so, as always, and do so spontaneously.
All right, thank you for your time then.
All right, thank you, Brian. John Matson. CBOR encoded certificates.
Yeah, so this is, thank you. This is about C509, CBOR encoded X509. And this draft is making, I think, quite good progress for eventual publication. The changes here since last IETF, there has been 2 updates to the draft submitted. Some of the new things are support for storing C509 in DNS. There was an earlier, the draft registering this register only allowed their encoded PKICs. This do an update, so CBOR encoded PKICs is allowed. Do you want to comment on here, or do you? Yeah, good. Yes, stand at the mic when you want to do your comment. Then there's some simplifications for extensions and special name encodings, thanks to Legion. CDDL review to Karsten, some updates to the CDDL, but nothing, just corrections of what was intended. Overall review from Brian, thanks Brian. There's a new section on deterministic encoding saying that if you have native search, you must use CBOR, etc. And then there's a registration of the C509 type in ad hoc authentication credentials. And this is not a register. This register was registered by a core for when you use OS core to negotiate or signal authentication credentials. And then there's a lot of editorial updates. Here are a list of the remaining issues. And we have tried to separate the issues into 2 buckets. One is, this is very needed for the core specifications. And the second bucket is, these are requests for extensions and like encodings for extension and attributes that could be done later. So we are focused on everything that needs to be in the core document, published then, and any extension, everybody has their favorite extension, and then you can register that later. Some of the remaining issues are encoding of the private key. Base trivial thing is to just encode as a byte string. You could do do we need optimizations for some of them? Do you allow like COSE keys as an alternative format, etc.? There's some duplication in text. This is mostly editorial. Extensions are explained in 2 sections. COSE, that has a separate slide. Then need to define CSR attributes. More questions, is there interest in designing a CBOR encoding for SCVP messages? It was open as an issue. And then media type for certificates by reference has been suggested. So that you, instead of getting a C509 certificate back, you get the reference back, and then you can use that reference maybe in some other protocol. No? I hope it's not delayed. 20 times. Some technical issues. We'll reboot the computer.
Ivo, can you try to put the slide deck back? There we go.
So, and here is issue 222, redefine COSE C509. The initial specification was focused on minimizing the sizes of everything, and then see if there is a good reason to expand the size for something is processing, for example. We're doing this, and this is a new proposal for Brian saying that we need to change byte string encode, wrap this in a byte string so that in some applications you don't need to understand the structure of this and go through it. I think that is a good point, and we're planning to do this in the or something like this in the next revision. I don't want to say that do exactly like this proposal, but I haven't checked that. Here is media type by reference. Also very straightforward, high level. Register a media type for a C509 certificate by reference. And then potentially you could download that certificate from there, or you could use the reference in a protocol that allows you to identify credentials by reference. And that is the next steps. We plan to wrap up the remaining issues. We hope that can be done until next IETF or before that, and then have reviews and working group last call. Hannes.
Yeah, hi. My concern with the document is that over time it accumulated all sorts of functionality, like often without any discussion on the list and any proposal. Like I see, it was initially about the compression of an X509 certificate, but then morphed into almost like replicating all the work in the BKIX world. Like CSR, we saw on the previous slide, like it got more and more complicated over time, and I wonder like where all this came from, other than from the authors. And that's why I support what Michael posted. Where's Michael? He's probably in the LAMPS meeting, unfortunately. But that's why I support what Michael said. Like, let's not get overboard on this document.
I think all the suggested changes has been very much discussed both on the list and in the meeting. I would say we have gotten very much, there's been request also to do revocation with both CLR and OCSP in different ways, which we have said that needs to be done in a different document. So
what you call very much discussed in meetings is mostly, and on a mailing list, is a discussion among the authors. Like the whole document hasn't gotten a lot of traction. That's why like adding more and more didn't really help the cause to make it any better. I
don't think anything like compression and native has been there more from the start, and then
CSR the native has not been there from the start.
Very early for like many years.
Because nobody cared, nobody looked at the document. That's why it's still there, and then you kept adding stuff. I think it should just do what the base functionality is and not do all these other things. Like it registers things for ad hoc. It does all sorts of things which I think were beyond the original mission of the document. That's my perspective on this document. I think it's not the way how we want to.
I really understand this comment. Like native has been there for many years.
And I tell you, I don't want it. I tell you, my opinion is I don't want it in there.
So Hannes,
I don't want the other things either.
Let's get back to the mic. My request as chair is that if you can verbally tell us, I'm giving you two choices. You can either verbally now or on list in writing. Can you write down what parts of the draft you believe should remain and should not, and your rationale for that, so that the authors and other working group members can react to that.
Yeah, I will reply to Michael's email, because I seem his email triggered my thoughts, because that's something that has been bothering me. Like, I've been asking like the people I know, who do you want to support this? Is this something you want to do? And like, it keeps getting larger and larger and more complicated. So I will reply to Michael's email.
Thank you. Bob Moskowitz.
I would like that we close with what issues are there and wrap this up and get it out. I have real customers. This is going to make a tremendous difference in protection for global navigation, for GPS. It needs to get done. We need to get this out as an RFC. Nothing new added unless something is found there. If there's any complaint I have against the authors, I would rather that they had done revs on the actual draft more frequently during its evolution. That after a month or two of things, that they got another release out. As we've long said, draft revs are free, but that's water under the bridge. We have something now. Let's all review it. Let's close it. Do the last call. Maybe some parts of it may not get used. That there's some interest in mega deployed, but I absolutely need this. And there are people and companies who are building against this right now. But for their final documents, they need this published. So anything that I can do, that we can do to get this done and get this out, please. That's my plea.
So I would ask you the same thing that I asked Hannes. Could you please say on list for us to finish the document, what parts of it you believe should stay and which parts you do not need? Because I do understand that there's impetus to finish this. We should probably finish it with only the things that people need now. Thank you. Hank.
If it's not wrong, if the other person is not wrong, do we need to cut them out? Unless we can say that those parts are wrong, are done wrong. I'll leave that to Hank to count whether they're wrong or not. And I'll drop out now.
Yeah, hi, this is Hank. Hi, Bob. Sorry you're not here. I think native meant something very different in the beginning of the document than it's now. So it might have been early in, but it means something very different today. So that is why I think also there was some feature shift. So I have to at least that supporting with Hannes here, that has a different meaning. Or I don't know actually why it's in there in this form today.
Can you just repeat that native have been there for many years?
Yes, but native meant something different many years ago than it means today.
I don't think so. I don't know when. Maybe a version like 00 individual draft was like.
Yeah, there was a lot of discussion with Joran about this and what to take from other work and I don't want to go into the details. I'm just saying there was a permutation of that. Okay.
Hank, I do want you to go into the details on the list.
Okay.
Thank you. I know I'm a broken record, but this is an important discussion. Anything else, John?
No.
All right.
I think we're done.
Thank you very much. Hannes, HPKE.
Okay, I keep it short for one primary reason. Our focus since the last IETF was on the development of the COSE-based version, because those two documents are, of course, as you can imagine, pretty much in sync in terms of functionality. So, and we got a lot of feedback and pressure to get the COSE-based version finalized. So that's where we had the bulk of the discussion and also the bulk of the updates. And it actually, for the COSE-based or the COSE-based version, it looks like we are very close to completion. Only a small number of open issues. Having said that, the document since has still gone through a number of changes. I would say they are mostly in the territory of wording changes. So if you look at the diff, it looks like we had done a complete rewrite. I hope that the changes we made help to improve the readability, and that's what where the time was spent. And of course, also with the alignment on to the COSE-based version. One bigger change that you may observe is, besides the wording changes, is the way we treat cipher suite labels. That was discussed on the mailing list. Mike led that discussion, and this is also in sync with the COSE-based version. So while this character is not properly displayed, you see the previous version. This is just a label. This is not what is sent over the wire. But there's a relatively long string, which we then compressed into sort of just HBKE and then a number followed by the number for the name of the cipher suite, because it contains a lot of information, and then it got longer and longer and longer over time, and that was a little bit problematic. So the structure of the cipher suite is simple. It has the HBKE modes, which is in this case, in this example, it's the base mode, but there are also these other authentication modes available as well, which the document doesn't provide any examples for, but it's possible to register, and so it is for the COSE-based version. Maybe we need to add an example here too. There's obviously the HBKE cipher suite combination as attached to it. In this case, like B256, SHA-256, and then it uses AES-128 GCM. So that's something that you as a reader will very quickly spot. As a reminder, this document version still uses the additional authenticated data, the AAD, and there's a recipient structure that Lawrence once constructed to put the appropriate fields in there. And that was proposed and used as a replacement for the COSE KDF context in the key derivation function. So it's a little bit a different design. In the COSE world, that is one of the open issues on how we best do it, and it's more likely that we will go there for the traditional approach, but that's not yet settled. When you look at the issue list, it looks like there's a lot of open issues, but instead we just haven't closed them. I will try to, with the updates that we made, with the editorial updates, we can close most of the issues. Have to go through the list and close them. Apologies for that. The alignment that's still ongoing, is not completed. Here's an example. As I said, we have these different modes, and in the COSE document, to distinguish the base mode from, for example, the BSK-based authentication or the sort of like public key-based authentication, the document uses two header fields, the ones listed on the slide here, and we haven't made that change in the COSE-based version yet because that was relatively new. So we still have to do that. That's the type of alignment I'm talking about here. And yeah, I talked about the last bullet. This was the key derivation function. We had a long dance on this. I spoke about this exact feature at the last IETF meeting in great detail. So if you care about those details, then have a look at it. And it's obviously a equally applicable to the COSE version. So it's not it has nothing to do with the encoding itself. What has changed out, however, though, is that there was a NIST document published, forgot the number, recently with a key derivation function for chems. And since we are using also as a possibility here, like the public key encryption is a chem, and we have also the variants for hybrid and post-quantum crypto here with HBKE as well. That is a new document that we definitely have to take into account. There's an issue in the GitHub. So what do we have to do? As said, get the Jose-based version finalized with this open issue that we have, and then make sure that we align the two documents so that there's no surprise to the developers. I think this is also a common practice for the other specifications. Like we have a lot of mirroring, like we've just heard the PQC presentations earlier. There's obviously corresponding functionality for the COSE world as well, and so this is true here. Hank, I saw you. You're gone? Okay. And then we are finally done with this. We have code, obviously, for both of the documents. Of course, with every change, we need to update the code. And we have been updating the code so many times already. So, but on the positive side, the examples in there are workable. So that's pretty good.
Who in the room has read the document recently? Hank has. Okay, can I get a few more volunteers to read the document? I realize it's not done.
But maybe when we do the in step 2, when we do the alignment, maybe that would be a good time to do the review rather than before, because
Indeed. Who is willing to read the document in detail after the alignment changes?
Steve, you are a crypto expert. Yaron, you don't want to review. Matthias, you're not crypto?
This is not crypto per se. This is packaging.
Packaging of crypto, though.
This is how we, no, I mean it. This is how we represent the use of the HPKE crypto, which was done in other documents as CBOR data structures. So it is a representation and packaging exercise. Familiarity with the cryptography is useful, but that's not what this document does.
Brent, you look down, so I think you are the ideal candidate. You are also a crypto guy. A coffee?
Have we gotten any volunteers except Hank?
Yeah. So, I will find some reviewers.
Okay. Okay.
And Brent says he will read it. Yeah.
Thank you, Brent. Okay, thank you. Now I'm going to take off my chair hat. Ivo is going to be sole chair for a moment, and I will talk about some new work. Hello, I am Mike Jones, not your COSE chair at the moment. I've done some work with my friend Emil Lundberg of Yubico in Sweden that we want to talk with you about today. So there's this notion we have of two-party signing. Let me talk about why we want this. The notion is being able to sign data using potentially an HSM or a FIDO authenticator, where you do not want to send the entire data set to the location of the private key in the HSM in order to sign it. It might be massive in size. Mike Unsworth, who couldn't be here because of a meeting conflict, gave us the example of, supposing you have a cat video on a DVD or something that's gigabytes and gigabytes in size. Even if you're online, you probably don't want to communicate that to your HSM as is. In the FIDO context, the communication may be over very restricted channels, such as NFC, Bluetooth Low Energy, and whatnot. And yet the private key is on the other side of that restricted channel. What do? The good news, which Emil noticed a while ago, is that many of the signing algorithms we actually use internally consist of two steps. One step is often some form of hashing of the data to be signed, and that's followed by steps that take the hashed value and do a transformation on it, which results in what we call a signature. Therefore, for some algorithms, and we'll talk about the nature of those algorithms, signing can be performed cooperatively between two parties. The application holding the raw data, which we'll call the digester, and the HSM, which holds the private key, can take the output from the digester and use it to create the signature. Now, the neat trick is that these signatures, even though they were produced cooperatively by two parties, they're verified in the same way that a normal signature is, because they have the same content. Now, Mike Unsworth gave us a friendly read on the slides. And one of his pieces of feedback is the name two-party signing might confuse people. In particular, as Emil pointed out, no, it's not multi-party M of N style signatures, which it could be confused with. So one of the pieces of feedback which we do want is what should we actually call this? So I've already described the motivating use case, but using my limited graphic design skills, I've made this diagram where you have, for instance, a cloud wallet, such as what some of my friends at Yubico and other places are doing. And then they're using a FIDO authenticator, which might be a YubiKey, could be something else, to sign the user data. And for those of you who know FIDO and WebAuthn, this is using a proposed WebAuthn extension where an additional key held in the secure element that's distinct from the FIDO authentication key is used to sign the application data. And for extra credit, you do get a key attestation on both keys, so you can validate that they're held in the same secure element, which for some applications matters. But now I'm far afield from what this draft actually does, but that's part of the background. As you can see on the slide, I mean, the WebAuthn signature is over this, fairly tightly constructed signature input, which is intended to be small and includes a hash of a function of client data rather than the client data, but is concatenated with the WebAuthn data, et cetera. So that's not good for signing user data. What we want is a key to sign the user data, and that's what the WebAuthn sign extension does. I was talking with people at the FIDO meeting in Melbourne about that a few weeks ago. So some of you who are cryptographers or are tourists in the cryptographic arena know that there's some things called pre-hash modes for some algorithms. So for instance, for RSA signatures, I know that's all of your favorite algorithm anymore, or ECDSA, you're free to split the pre-hash step from the core signing step. So in the first example, the cat video is sent in its entirety to the HSM, and then a signature is applied. In this case, RSA SHA-256. In the second example, a SHA-256 hash is sent to the HSM, and an RSA encryption step is applied in the way that RSA signatures work. And the beauty is both modes produce exactly the same output. So this is just an internal implementation detail of the signing. The signing, the signature validation happens exactly the same, no matter which you do. And this slide is courtesy of Mike Unsworth, who produced it for an entirely different talk, but we were, having a conversation during the hackathon about what are you doing? And I explained what Emil and I were doing. He said, oh, I support that. Here's a slide describing exactly what you're doing. So this specification proposes to allocate new COSE algorithm identifiers for these two-party signing steps so that the party holding the private key can know you're being asked to sign with the already hashed or already produced small data rather than over the entire signing input. That's distinct when doing two-party signing from the steps that you would do if you're doing the whole thing. In particular, you skip the first part, whatever the first part is, and we'll get to that in a subsequent slide. But it is not the case, because cryptographers are clever and do some things differently for some algorithms. It's not like you can always just say that the digester does a hash. In fact, sometimes the digester would do a hash over the data concatenated with something or transformed in some way. So there is not an algorithm agnostic way to do this. In fact, we'll talk about in a slide or two that for some algorithms it's impossible, which is okay. So because there is not an algorithm agnostic way to do this, you have to say for what algorithms you are doing it and in what way. And in fact, part of that's going to be to make it fully specified. You have to say what hash function you're using, because sometimes you have a choice. So it's obvious for ECDSA and RSA what to do. It's non-trivial for Schnorr signatures because there's a hash over a signer chosen nonce. It's non-trivial for MLDSA because the hash is over the context prefix and the public key. And arguably the context prefix should be controlled by the signer. Also, there's a LAMPS discussion, which there's a link to in the slides, about whether to use the external mu MLDSA form or the hash MLDSA form. And some of you in LAMPS are familiar with this. Those of you who want to seriously evaluate the MLDSA part of this draft probably want to understand the background of the LAMPS discussion. There's algorithms for which this is impossible. The pure EDDSA hashes over the private key, and part of the division of labor here is that the HSM holds the private key, which may not be extractable. So the private key is not available to the digester, the first party. When that's the case, you can't do this at all. Therefore, as we've already said, there's not going to be a generic division of algorithms. It must be algorithm specific, and we're going to need algorithm identifiers to say when you're doing this and how you're doing it. So, you know, for EDDSA, there's issues which we can talk about some more. In particular, the issue which I went over on the previous slide is if you have to know the private key as the digester and not the signer, this doesn't work out. So the next 3 slides are stolen from the draft directly, and they are the two-party signing algorithms that we're currently proposing to register in the draft. This is an individual draft, not adopted, it's new. All of this is subject to change, but we thought we would put down a starting point. So the easy stuff is the ECDSA algorithms. And given that over in COSE or in JOSE tomorrow, we'll be talking about the status of the fully specified algorithms draft. These would be divisions of the fully specified COSE ECDSA signing algorithms, not the generic one. We propose to define two-party algorithms for the hash EDDSA, two-party algorithms. Note that the pre-hash versions of these are not yet registered. That may be something we want to do in cooperation with this work. And the hash MLDSA algorithms, while there's OIDs for them in CMS world, there's not COSE or JOSE algorithm identifiers for them yet. So for this to become real, we would need both the two-party algorithm identifiers and the normal single-party algorithm identifiers. These are not necessarily the only algorithms that we could do. We don't have to do all these algorithms. This is part of what we want the working group to look at. Now there's another twist. Again, because cryptographers are clever, some things are different between algorithms. And in particular, some algorithms have parameters that are used when signing, for instance, to provide context so that the signature for context A is different than the signature for context B because you have a context input. MLDSA is such an algorithm. And for two-party signing, these additional parameters, such as the MLDSA context, have to be communicated between the digester and the signer. And Emil defined a way of having what he calls a key reference, key representation, where you put these in the key reference alongside with the normal key material. And we'll show you some examples of that. This enables a unified algorithm agnostic protocol to be used for this by using these key references. But you still have to look inside the key reference to pull out your algorithm specific parameters. So here's two example key references. And again, these are in the draft. One is for an ECDSA curve using P256. It does not have any special parameters. So unsurprisingly, the key looks like the key material for the ECDSA key. Where the second example, an MLDSA 65 key, does need to provide an additional parameter, in this case, the context parameter. And so for these key reference types, additional key parameter values proposed to be referenced, in this case, -1 for the context argument. And so it would go for any such algorithm where you do need an additional parameter to be communicated between the parties. So I will ask now as an individual the same question I kept asking as chair. Are there people that are willing to read this document and provide us feedback on it? Hannes, what a guy. Brent, in the same what a guy category with Hannes. Yaron, thank you very much. And again, all are free to read this and any working group documents, but thank you for the volunteers we have. I know Mike Unsworth is also a volunteer because he told me so during the hackathon. So that's the first next step. The next step is there's a few places in the document, and indeed I pointed them out on the slides, where there's things that would be the single normal signing algorithm that are not yet registered, which we want to have corresponding two-party algorithms for, and we should register those. We could either create new drafts for them, or we could do it in a subsequent version of this draft, and opinions on that are welcome as well. What other next steps have the authors not thought of that you want to tell us about? I just thought of one on the fly. One is, to the extent that any of you are involved in WebAuthn or FIDO2, it would also be great to get your reviews on the proposed signing extension. Because all of this for our use case is predicated on the signing extension going through as part of WebAuthn level 4. You'll see that I made a blog post yesterday about the FIDO Alliance just finished the third CTAP2 specification, and the W3C is in final review stages for finishing the third WebAuthn spec. So we're on to V4 pretty soon, and this work would happen in V4. At this point, I invite people to come to the microphone, and I see Bob Moskowitz is first.
Yes, just from the chat. Since I'm using EDSA, you didn't mention it, I asked in the chat. And Christian says it doesn't work. So this implies that the draft document should include those algorithms that don't work this way. You must specifically call out those that, if you want to use this algorithm, you must do hashing as a totally separate function that you're signing a hash or something like that. Make it clear those which don't work.
Good
Thank you.
feedback. Thank you. Who is next in the queue?
Yaron Sheffer. I have a vague gut feeling about this. It's the first time I'm seeing it. I don't like it. I will review the draft, of course. I think we're folding system architecture and even the threat model into a code point. At the very least, it doesn't look to me like something that this working group should be making a call on by itself. I think it should be coordinated more widely across multiple protocols and certainly encodings. And then weird points like, what does proof of possession mean? Do I actually possess something when I'm just this hasher part? So it's all quite weird.
It was weird to me at first, and Mike Unsworth said to me during the hackathon, well, you actually don't need this. You can just use the normal algorithms. And I pointed out that the party holding the private key, the HSM or the secure element or whatnot, does need to know whether the input it's getting is the full message or the pre-digested message in whatever way that's algorithm specific. So you do need, if you're going to do this at all, you need to be able to say in some form that you're getting the pre-digested version. And, and there may be, and the reason I convinced myself that you need algorithm identifiers is it's not like there's just one way to do it. With RSA, you could do the hash using an old algorithm that I know something about. You could do the hash with SHA-256. You could do the hash with SHA-1. You could do the hash with, other things. And so you actually have different algorithms depending upon what the digestion step, boy, that's a bad word, does.
Indigestion.
But thank you for being willing to, the indigestion step. Thank you for being willing to read.
Yes, please share your review after you read it. Thank you.
Hank, you're
Then
next.
I see Hank.
Hi, this is Henk. I almost forgot what I tried to mention. So first of all, I assume that most people that have a strong opinion on this are in this room because we conflict with lamps and all that. That's a little bit sad. I'm not a cryptographer. Cryptology is weird. Also, what I hear and multiple times because we're doing the hash envelope was that hash MLDSA, nobody's going to implement that. And that is just something I repeat like a parrot. I have no idea why this is an opinion, but it is a hallway opinion that I heard more than a few times. And because again, we're doing the hash envelope and it's kind of a little bit like that. And that is why I got that feedback early on. When we explained our use case, it seems to be, yeah, okay. But I can see if that is an opinion out there that we need people in here who can explain why I'm not that person, but just to highlight it.
Again, Mike Unsworth, who's the person who told me about this a few days ago, said in private communication that part of the problem is there's separate OIDs for MLDSA and hash MLDSA, but the key representation is the same. And it's difficult then in CMS because you don't know in time which algorithm you're using. And so some of the cryptographers had said, simplify your life, only use one form. Where there's a third form for MLDSA. And again, I am also not a cryptographer, nor do I play one on TV. So but there's cryptographers who say, oh, there's another way to do this. So this is part of a good discussion. I'm glad to be among people who know far more about this than me. Well, thank you.
Kristen, just a brief question. Given that there's already the need to have an object that describes more of how that signing is to be happening in detail, can't that way how it is designed for that, how it is to be signed for that particular algorithm, not just be passed in that object rather than allocating code points for like every other signing algorithm?
I didn't hear the key point of the question.
Sorry.
Emil, did you hear it?
Given that there is that other object already that you need to pass along for at least some algorithms, can't the information that this is happening, and in case of doubt, how for that particular algorithm to be passed in there?
There are certainly other ways to factor this problem. You point out correctly that the key point is that the party doing the digesting has to somehow communicate to the party doing the signing step what's happening and what steps they've performed before handing off to the second party. This draft is a way of skinning that apple, but it is not the only way you could factor it. So particularly if you could put that idea on list, that would be fabulous. Emil, what have I failed to say?
Thank you, Mike. I think some of the points that are coming up in the chat, stuff like that. One of the main things that we want to achieve here, specifically talking about our proposed FIDO signing extension, which is the motivating use case, is that we want to be able to create signatures with hardware-backed keys in a way that's as useful as if you were using platform APIs, for example. Yes, one of the points that didn't come up is you can use the pre-hashed variants of the signature algorithms for this. So for example, in EDDSA, there is a pre-hashed version of EDDSA where you essentially hash the message twice. Once just hashing the message and then afterwards hashing that hash with a private key. And that's designed for specifically these kinds of use cases where you don't want to send the entire message to an HSM. But much like hash MLDSA, that requires a separate verification procedure. So pure EDDSA signatures verify differently than hash EDDSA, and same with MLDSA and hash MLDSA. They are different verification procedures and they are different signature formats. So if there are applications, for example, that use pure EDDSA or use pure MLDSA, then if you have a hardware element that can only do the hash variant, then that hardware module is not useful for those applications where you need the pure variants. So that is why we want to also support the pure variants across this hardware divide. And of course, if Michael Jenkins pointed out in the chat that he would expect the cryptographic library to take care of these details. And yes, I agree if the cryptographic library is monolithic. But if the cryptographic library is split between a user space host and a discrete, separate hard secure element, then you need some way to communicate across that split. Which algorithm are you performing? Are you supposed to do the entire signature algorithm or only the things after the hash, essentially? So mostly this is a way to address that so that different vendors can interoperate and still support these pure versions of signature algorithms across that kind of split between client and secure element is the main idea. And I think I was going somewhere, but now I lost my train of thought. But yeah, and also on the topic of MLDSA, I put the MLDSA or hash MLDSA in the draft mostly as an example for what this would look like for that kind of algorithm. I do not have a strong opinion on whether MLDSA or hash MLDSA should be the thing people use. I am more than happy to drop things from the drop algorithms from the requested allocations and so on. Right now, the main things we're actually interested in using in practice is P256 ECDSA, and soon also Schnorr signatures on the BLS curves, but we are still prototyping that and haven't worked out all the details yet. Yeah, I think that's all of what I had thought about adding. Thank you, Mike.
Thanks, Emil. You're in the queue.
So if we need to support these decoupled signatures for some cases for optimization reasons, performance reasons, that's absolutely fine. But let's not move the responsibility from the signer side to the verifier side. As far as possible.
Completely agreed.
So from a policy point of view, the verifier should not care. The verifier should assume that the signer is at the correct level of security for whatever it is they're doing. It should not care about the internal separation.
Correct.
And if at all possible, it should not see like strange artifacts other than this indication that the algorithm is a little bit strange because we needed to do this optimization.
Indeed, part of the asymmetry of this is the signing step is broken in two and is described with one algorithm. The verification is not broken in two and is described with the unified algorithm that corresponds to the two-party algorithm. So if you look in the draft, each two-party algorithm corresponds to a normal algorithm, which is what the verifier would use. The verifier doesn't see or care about the two-party algorithm.
So why do you need a code point then?
Because in the signing, you need to communicate what the digester did to the signer.
Okay,
That
I still
occurs
don't
with the
understand.
code
I'll
point.
read it.
Yeah, this is something I've been thinking about too, that in the draft, we specify that these new code points shall not appear in the resulting signature cryptograms. So these code points should never be exposed to verifiers. And that kind of limitation that you should not use these code points in all places you can use COSE algorithm code points, it's a bit of a design smell, to be honest. Maybe this should be a separate registry in some way that shouldn't be in the same pool of algorithms as the usual COSE algorithms. That is definitely something to consider. But yeah.
Michael Jenkins.
I heard Yaron earlier say he didn't like it, and then I just heard him say something that sounded odd to me. Generally, which was, we should assume that the signer is following an appropriate signing policy, and the verifier shouldn't need to know about it. The verifier is the one who cares how it got signed, which I thought maybe was what you were, what this was all about, was a way to indicate to the verifier, that that the hash had been split off from the signing function, which the verifier may care about. I don't. It seems odd. What I thought this was originally was like you were going to put some kind of flag, some kind of marker that said this had happened, but leave the identifiers alone. If I'm not sure how it works to use one identifier on the signing side and then a different identifier sent to the verifier. That seems disingenuous.
It's
because
because
it's the
the two are paired. There's,
So
there's a correspondence in the registry.
I get what you're saying, but you're making a separate identifier on the signing side because you need it functionally, but then to the verifier you're saying we didn't do anything different, right? But you did. You did the hash outside of the crypto module, or you did it in a different crypto module.
That's an implementation detail, though.
If the crypto modules are linked in some way. I mean, so MLDSA apparently, well, external mu apparently does this, and it's of concern to me because you're pulling something out of the middle of a signing algorithm, and you're saying, well, I'm going to do this over here, right? And then I'm going to send it over there, and that sending it over there, that concerns me, right? I mean, what's in between? And the verifier may care that you did that. At the moment, there's really no reason to have a separate identifier for MLDSA because you have this, you can bury this external mu thing, down below the covers of it. The signer can just say, do MLDSA and not worry about how exactly it worked out. And the verifier can too, as long as that's all kind of taken care of. And it's that taken care of thing that bothers me. And if you wanted to indicate that had happened, I would say, yeah, that's a decent thing to do. It seems weird to me to break them apart and then to not tell the verifier and say, well, it's on the signer to worry about the policy of splitting it apart. In other words, the fact that something is hardware signed or not hardware signed may be of interest to the verifier. But we would normally do that through certificate policy or something, I guess.
In the FIDO world, you learn that by looking at the attestation on the signing key. And indeed, one of the things that we haven't talked about here is that used in FIDO and WebAuthn, you would get the same kind of key attestation saying that this key is held in the same secure element as the FIDO authentication key. That's pretty far afield of what we need for COSE, but you're correct that having key attestations may be important to the verifier in some application contexts.
Also, as far as I understand, this is also how other protocols like OpenPGP work. I have only been told this secondhand, but apparently in PGP it's the same thing. The data to be signed gets hashed on the client, and the smart card only sees the hash. So as far as I understand, this is common practice in these kinds of smart card protocols already.
I don't doubt that. The question is, are the apps going to have to know about these two separate algorithm identifiers? Do the apps have to know whether they're signing with hardware or not? Or do they just say sign and then the underlying system says, oh, well, I have a hardware thing, but maybe I better do this pre-hashing business?
Depends on where you draw the line of application.
Yeah.
But verifiers should not need to know.
No, I
the
agree.
application interacting with the user probably needs to know, but the application requesting that something be signed does not need to know.
Okay, thank you.
Hi, Brent Zundell. It seems like what this would enable is a greater separation between the action of hashing and the action of signing. Whereas, if we're, the smart card example, in theory, I have the smart card. As the user, I'm in control of both operations. Whereas with this, we're widening that gap and enabling potentially different control between those operations. And I think there are potentially some subtle security considerations with that separation that at the very least should be communicated to the verifier, even if the verification process itself doesn't change. It's still, I think, valuable information for them to know.
Note takers, can you record that? That's useful feedback. And Ivo, there's other AOB presentations, at least one by Hank, that was submitted. You're the timekeeper at this point. So cut this off when you want to give time to Hank. But I think we have a lot of time left.
I mean, I think maybe after you can, after him, let's get the mic for now, and we can move the discussion on the list because we have the hash envelope, and I think something more.
So I'll make it short, both to answer Michael and referring to what Brent just said. There's tons of potential policy information or knowledge that would be beneficial to a verifier, but I don't think that the code point is the right place to contain it. So are there timing side channels on the signer side? That's very relevant, very interesting. It's not communicated anywhere. So I see this thing as internal architecture, and that's part of the contract between the signer and verifier. If the verifier needs to know more, there are key attestations or whatever, but this is not the right place for it, in my opinion.
Okay, thank you. So with that, I think we will be waiting for some reviews on the mailing list, and then we'll see how to proceed with this. Thank you for the presentation, Mike, and all the participants in the discussion.
All right, and thank you for all of your time. Thank you, Emil, for dialing in.
Thank you all.
I think we can continue with the hash envelope draft.
Hello, I'm Steve Lasker, and we'll talk about COSE hash envelope today. Our main intent with this is to be able to solve large or duplicative payloads when you're trying to integrity protect them. And so we've got a set of header parameters that help you understand that the payload is actually a hash. And so we'll go into the details about that. So,
can you speak in the microphone, please?
Oh, I'm sorry. Try a little better angle. So let's just review a little bit of way the basics work, right? So there's the inline where you have a protected header that you're specifying the content type, and there's additional information you could put in it. And then the payload. The payload can be, anything. So, and then you take that protected header and the payload and sign it, which you also need to verify. So the challenge that we've seen with this is when the payload is, we don't know how big, right? It could be a small string. It could be a vcon, and a vcon could be a small set of data, or it could be the entire media file from a 1-hour recording. So that can be fairly small, or it could be pretty large, kind of defeating the purpose of what we're trying to do with the COSE envelopes. So great, we've got detached payloads. That is a great solution, partially. So in this case, you start with the payload because you still need to create the signature about it. And then you detach it and nil it. So, okay, now the COSE sign one envelope is small, except when you go to submit that to a service, or you're trying to verify it on the other end, you don't know what you're supposed to do with that. You have to assemble it yourself, some assembly required. And that itself is okay. So we can put in the unprotected header a location, and that seems like it's good, except that you may not have access to the location. Or again, we're back to what if it's very large? Am I really trying to integrity protect the entire file, or can I integrity protect through the hash? So by going with the cache envelope, our goal is that we can get a hash of it with existing algorithms, and then you can integrity protect that and verify the signature without having to get the entire payload. So in this case here, you'll see the new headers are added. We take the payload, and whatever it may be, in this case, we don't know the size per se. It's some string with a bunch of dots in the middle. We have a hash algorithm. We have the pre-image content type. We do not use the content type. We specifically say pre-image content type. And there's an optional hint. We debated on calling it hint location, but that doesn't mean you have access to it there, or that's where you have to fetch it from. It's just a location hint. So now, because the signature is based on the string that's in the string, the bytes that are in the payload, which is a hash, and we know that by looking at the protected header, now it can be verified without having to go get the large payload. So there's a lot of gatekeeper kind of scenarios where you're trying to verify that there's a payload that comes across and references some large content. Could be a vcon, could be a Docker container image, it could be a media file, it could be a LLM. So that data can be fairly large, but we want to be able to get the hash and verify that first. And as long as that's good, then we can pass it on. And then the next step down the line, probably, depending on what they're trying to achieve, should take that hash and verify the hash matches the content before it proceeds. But that's out of scope of what we're trying to do here. We're trying to say, here's a hash, and here's how you can verify it. We did get allocation since last meeting, so thank you, Hank. We now have the 3 new headers pre-allocated. So since 121, which of course that's one of the things we did get some feedback, and we incorporated most of it. So here there was actually just a typo in the sample where the hash algorithm was optional. So I'm just highlighting it's not optional anymore. There was a request to clean up references to COSE encrypt and some of the FIPS references. So the rewording is here. I think Ori did that. I can't remember. So thanks to whoever's back behind that PR. And then we discussed at length a proposal for a pre-image content type, pre-image content size / length. And we were really kind of drilling into what were the scenarios we were trying to solve there. And it became more of a DOS kind of a scenario where, am I trying to understand how many bytes should I fetch before I shouldn't go any further? And the more we talked about it, that information is in the transport. It's either in the transport of the location of where you're trying to get it, or if you're referencing that hash to know if you already have that content locally already, then you can do it in other ways. So we basically, after lots of discussion back and forth, we decided we didn't think that was appropriate to pull in. So the request for pre-allocation, so I kind of did a spoiler alert up front. We did get those set. So they're kind of self-explanatory here. And we do have multiple implementations around this already. So while the pre-allocation was done, it was because the other ones we were using private references, private numbers to make progress on this. And Microsoft was trying to ship their tool. They were already using this pattern of using hashes. So we've been working with them for quite a bit to say, hey, can we adopt this pattern? They said, yes, if you just assign some numbers. So we went and got that done, and they've updated the COSE sign tool. Go COSE library just got these updates, and the GitHub Actions and the vcon stuff in the bottom half are using the private entries that will switch next week. So good reference implementations, and it works really well to be able to know that it is a hash and what the hash algorithm is. So with that, there was the only other feedback that came in yesterday or today, depending on what time zone on the rock we are, was the content, the pre-image content type, I believe it was, did not specify whether it was a must or whether, sorry, it's an optional or it is must, but we didn't specify whether it had to be in the protected header or the unprotected header, and that left some ambiguity, and the Go COSE library kind of surfaced that. So there's a PR, and we just haven't had a chance to discuss it, but I'm sure we'll come up with, it just seems obvious to match one of the other ones that it must be in the protected header, because it is a must, so I'm not sure why we would put it in the unprotected header when there's no real good reason for that. So with that change, we can push that up pretty quick. We believe we're ready for last call. It's a fairly tight spec, and would love additional feedback if we don't think we're there. That's it. Questions? None? I saved you some time. Thank you.
Stay here for a minute.
I get called.
So it seems to me that your analysis is probably correct, that we would be ready for a last call after you address the known issues that you spoke of from the microphone. Does anybody in the room believe that that's not the case? Either the physical room or the virtual room? If so, please add yourself to the queue.
I'm just trying to get off stage without coughing.
Seeing no one in the queue, let the minutes record that we will start a working group last call once the authors identify to the chairs that you've done the issue resolutions that you believe need to happen first.
Sounds great.
Okay.
Thank you.
Now you're excused. And we're now in the all other business section of the agenda, I believe. During the meeting, a slide deck came in from the Laughing Party across from me. Would the Laughing Party like to come to the microphone and speak to the unknown slide deck? There's never enough time, Hank.
Yes, now there's enough time. Wonderful. Hi, I'm Hank. So Hannes and Brandon basically prepared this wonderful idea of, well, you know, CWTs are signed, and the signer of a CWT could say that with a CWT that looks very familiar to a certification path. So what we have here is previous work. Oh, this is really far away. So what we have here is related work. I assume that the first work is the representation of X519 certificates in the COSE parameter header, because I see a 9 in the RFC number. That's all you can see from here. So there is existing work that has the X5 view, the X5T, and the back and the chain, you know, the header parameters to reference X509 items. There's other related work, of course, the compression ID that we have talked about also delves into that a little bit. There is a, I think at the moment, expired ID that tries to do that for the OpenID trust chain. That's relatively sparse. The one line of CDDL that I can read did not mean a lot to me. I think that's an early draft and currently not worked on. So, but again, CWTs are things are signed. The signer can also issue a CWT saying that. That is very similar to a certification path. So we are using all the nice ideas by the X509 representation. We have a back and a chain and a thumbprint and a URI. I think that's, I'm going ahead myself because that's on the next slide. But and that would be something useful for very constrained items that could be very benefit from a CWT certification path, especially here. Suit is an example, but I think there's more and more IoT devices that could have this kind of hierarchy. And so we basically have some inclusive constraints here, of course. I'm not entirely familiar with all of them. If Hannes has to add something at the end, that's fine. But there's a confirmation claim, of course. And you have that as an example from 8747. I think that's the number. I know the number, but I think that's a reference from here. So again, this is basically a certification path. And we mimicked, as I said, the back, the chain, the thumbprint, and the URI. And have some nice extra feature for the static key agreement that could be useful. And that is the bare minimum. I think we don't want to go way much farther with this idea and this ID. It's useful as it is, but maybe we can have something like a usage added to each of these items so that you know you're now actually following a certification path, and that's the intent of the CWT. So that is maybe something we can do as a next step. And hopefully, this has basically no feature creep otherwise, and is a quick ID that can go to a conclusion relatively soon. But we want to present it here. Sorry, today. The agenda was already full when we had the slides. So this is the any other business for today. It is one item. And I think that's also the end of the presentation. So we want to make you aware, right? Sometimes the CW2 is enough to be a signed public key, so to speak, a micro certificate, and then you go with a certification path. Yeah, a lot of IoT application probably can benefit from that concept. Hannes, not once if this is enough to say. Done. Okay, this is my short presentation, and I think we can again work a little bit about the purpose, because then you can really have there a lot of flexibility, and then we will present the thing again, show some excerpts of the existing ID. Maybe probably read it now. If you think certification paths and very small CWTs is a good idea, have a look, and we will come back next time and probably already ask if this is ready, because this should be very straightforward. If it is not, the review will show so.
As an individual, what claims are used in these CWTs in a certification path? And does the draft say?
Well, the obviously the pub key is represented because you have to have your own asymmetric key pair. That is these represented by the CWT that we look at, and it is signed by the private key of another. So basically, it's a pub key. That is the relevant item here. And the issuer, yeah, of course.
Yeah, I was going to say, you probably want
they go hand in
the
hand.
issuer to be required.
Yeah, of course, yes. So those are to find the owner of the pub key, of course. You can have indices, services, and resolve, but no, issuer, of course, is an obvious choice. Yeah. And that's a minimum thing. Basically, what we're talking about is a chain of minimal identity documents with existing technology. Yeah. And it's a cool idea. I think. That's all. Thank you.
Is anybody willing to read the document and give the authors some feedback?
You can hunt you down the hallways.
So as an individual, I'll volunteer. I've certainly done work close to this in other places.
Kirsten and Christian and Roy will do it as well.
Perfect. Wow, then we have 4.
Okay, let the minutes record those.
Enshrine this in the
persons.
minutes.
Yeah, enshrine all of our names.
And later it's skit, but this is a future thing. Okay, thanks.
Okay, with that, we have 10 minutes left in our previously entirely full agenda. People are free to add themselves to the queue to talk about anything COSE related. Christian.
Hi. I'd like to take that opportunity to ask a bit around whether at any time in COSE applying grease to header parameters, that is, introducing items that don't have any particular meaning of their own, but that are not used as critical, has been discussed already, or whether that is common practice, because we are starting doing this in Lake, in ad hoc, and turns out that for the COSE side, we're not the experts. So I'd like to get feedback on that. There's a mail on the list too.
So if I heard you right, there's mail on the list that you want people to respond to. Am I correct?
Yes, and it is on using code points that have no other meaning than people. People should ignore them as they ignore other code points that are not that they do not understand. So there's no need for users to process them, but it is there to ensure that they don't fail when something shows up that they cannot process.
Okay, so people are asked to look for the code points email and give your feedback on that. Thank you. Any other volunteers? Steve Lasker is coming to the mic.
So was that Christian?
Yes,
Okay,
Christian.
Christian, so I'm curious because it sounds like something we have also been playing with around what we call a meta map. So you can put in information in the COSE header that can be understood by parties that want to look at it or ignored by other. So I can send that to the list because I've been seeing that come up in a couple different places and I'm trying to get some more thoughts around it. So I'll share that.
Thank you.
Right, anyone else? Going once. Going twice. Okay, thank you all for your active participation, both here in Bangkok and online. We'll see you on the list. Thank you. Bye-bye. And thanks, Eva.